Rachel, and thank you to all of you who have joined us today. We're super excited to have this conversation. You know, the interesting piece with our member webinars is they really tend to get deep into the details of what's happening in transportation and in safety and in technology. And that's what we're excited about for the conversation today. And just a little bit about that conversation, we're actually interested in hearing from you all as well. So there's going to be some times I'll ask you to look on your chat function where we might ask you a question as well, your perceptions of what's happening in the industry, what you're seeing in technology, so that way we can engage our panelists in talking about these topics more robustly, and frankly, tap some of your expertise too. You know, what we're focused on right now, and apologize as you hear a fire truck go by my house here, but we're here to talk about pedestrian safety and really safety on our roadways. But when we talk about safety on our roadways, we recognize that our fatalities continue to go up for our most vulnerable road users. And in doing so, we know as it goes up year to year that there are technologies and tools at our disposal on how we can implement those to improve the results that we see on our roadways, to literally save lives. And one of those is our Lidar-based technologies. And we wanted to talk a little bit about that today, how Lidar is really infusing our autonomous and automated driving systems, how it's impacting our advanced driver assistance programs, and how it's really being incorporated into intelligent infrastructure. So we're excited to have today to join us in that conversation, three really excellent speakers who can talk about, for instance, how this is happening. So we are joined by Olivier, who is the Chief Technology Officer with NAVYA. Many of you have heard of NAVYA as one of the leaders in deploying autonomous vehicles and autonomous shuttles in the country, as well as internationally. Blue City Technology and Asad Lesani. Asad is the CEO of Blue City Technology, and they are really weaving innovative transportation and intelligent transportation with intersection technology and detection as a way of moving towards vision zero and zero deaths on our roadways. And then ultimately we are hosted by Velodyne Lidar, who is the secret behind the sauce here in how we see. And when I say see, I'm going to put air quotes around that because I think we all recognize that LiDAR is a technology that creates a capacity to see far differently than we have been historically. So as we go into this, I wanted to actually start by asking Nikhil to start and introduce a little bit of Velodyne, explain why we're sitting here and talking about LiDAR, what's its role in how we're looking at zero deaths, and how does a technology actually make something like this happen? Nikhil.
Thank you, Amy. And hi, everyone. Good afternoon and good morning, depending on where you are. I'm happy to talk about Velodyne Lidar and our efforts to improve pedestrian safety and reduce pedestrian fatalities, which you will see is a common theme amongst all of the different markets and use cases and industries that we supply our technology into. So let me share my screen and share a presentation about who we are and what we do. So Velodyne Lidar has, as a company, has existed since the 1980s. Back in the 1980s, the founder of Velodyne Lidar, David Hall, built one of the best acoustic systems and built that out into a very large business. In 2004, there was a DARPA effort to make cars more and more autonomous. The government actually wanted more autonomy on our roadways because they knew right from the beginning that this is going to be a game changer when it comes to safety of drivers and pedestrians. And Velodyne Lidar competed in the DARPA Grand Challenge, got some key insights from the race, and invented the first real-time three-dimensional LiDAR in 2005 and started commercializing it in 2007. Today, we are the world leader when it comes to 3D LiDAR. And our LiDARs are essentially revolutionizing a number of different industries. We bucket the sectors that and the markets that we sell into three categories. One is the delivery of goods, where we're enabling be it autonomous vehicle companies or ground robots for last mile, first mile, and middle mile transportation of goods. In the automotive sector, we are enabling both driver assistance for passenger and commercial vehicles, as well as full autonomous driving for what's known as robo taxis and robotic shuttles. And then finally, in the smart city and security sectors, our lidars are enabling infrastructure monitoring and pedestrian monitoring at intersections, infrastructure monitoring with drones, etc. The common theme, as I said, is pedestrian safety. Pedestrian fatalities, unfortunately, are on a rise. In the past 3 years, it has actually gone up. And as of today, we see in the US close to 6,200 pedestrian deaths per year. And this has been increasing year over year for a number of different reasons. And this is a problem because our roads are should be becoming more and more safe. Our intersections should be becoming more and more safe. But unfortunately, pedestrians and vulnerable road users are, the fatalities being seen in that group is on the rise. And when you sort of look at this with with the magnifying glass, you can see where this happens. It's quite intuitive. A large number of these, close to 75% of these deaths and fatalities occur at night. The kinds of scenarios where this happens is pedestrians crossing streets at night when there isn't enough street lights, when they are perhaps inebriated, and that leads to a large number of deaths. And that's in fact captured in the FARS report from 2018 that talks about why this happens and what are the reasons. And you can see that it's not just the daytime, but nighttime is something that needs to be addressed. Now, at Velodyne Lidar, our technology is very, very useful and instrumental, especially in those low light conditions, as well as inclement weather conditions. So here you see an image on the left where you have a photograph that has been taken with an automotive grade camera in a parking lot. And you have two pedestrians walking in front of the vehicle with streetlights, and the pixels in the image are hardly intelligible. It's hard to say that there are two people there. In one case, you can see a person's legs because of the headlights of the vehicle, but otherwise it's very challenging for a camera-based system to detect pedestrians. Juxtaposed on the right, you see the image that is rendered by a LiDAR. A LiDAR is an active sensor. It stands for light detection and ranging. It produces the energy and spits that energy out into the world, throws it into the world, and then measures the returns. And so it doesn't rely on ambient lighting, making it extremely useful for these nighttime scenarios. And as a result, making it an excellent system for machine-related applications and automated applications where you want to have a smart vehicle, smart infrastructure, etc., that's capable of understanding who's in the environment and protecting our vulnerable road users. So in that effort, we did a study where we took two vehicles, one vehicle which we equipped with our Lidar-based technology for pedestrian emergency braking. PAEB is an industry term for pedestrian automatic emergency braking. We installed this on one car and integrated with the car's control system. And we tested using mannequins and dummies in basically nighttime scenarios where we drove towards the object and consistently the vehicles came to a halt. Our objective was to stop the vehicle within 1 meter of the pedestrian dummy, and we were able to accomplish that successfully over a number of different runs. And statistically, we were able to see that the standard deviation was about 9 centimeters. with a mean stopping distance of 1 meter. So this kind of precision when it comes to braking to avoid vulnerable road users and to avoid collisions and fatalities is going to be key for the next generation of driver assist as well as autonomous vehicles. We compared against a camera and radar system only to see that what the performance would be like in this exact setting, and the failure rate is high enough that it cannot be ignored. Camera and radar systems work beautifully in certain conditions, but as soon as you start looking at nighttime, and as soon as you start looking at scenarios where there isn't enough ambient light or inclement weather, a camera-based system can fail. So each sensing modality has its pros and cons, and the combination of the three is something that really enables very high levels of safety, both for the passengers and the people inside the vehicle, as well as the pedestrians and the vulnerable road users outside the vehicle. So, as I said, in that study, we conducted a number of different experiments and scenarios. We tested scenarios like a adult pedestrian dummy crossing the street at the center line, all the way down to a child dummy crossing the street, a fallen adult, etc. And we had a very high success rate. Our precision and recall was extremely high to make this a usable system. And when we compared against the camera systems and the radar systems work. It's just that they are not capable of working in all scenarios. They work well for certain scenarios, they don't work well for others. So really what we are excited about is introducing LiDAR as that missing third dimension for enabling better pedestrian safety and reducing pedestrian fatalities. This complementary sensor really makes the entire system robust and capable for having smart cities and a Vision Zero future. Thank you.
Thanks, Nikhil. And as we go into this and we transition to Asad to talk a little bit about smart cities and infrastructure, I think it's probably important to talk about that one big elephant in the room that everyone always asks about. In fact, we already got a question on it, and it is when you talk about the missing third dimension, the comments of Elon Musk and others to suggest that LiDAR is a tool that is more complicated because of its inability to maybe penetrate, heavy fog or snow or things like that. And so maybe let's talk about that a little bit right now, because I think as we have Asad get into his discussions and as well as Olivier, the intersection of those three technologies really enabling us to see better. But perhaps you could talk a little bit about that.
Absolutely. I think at the end of the day, it comes down to complementarity. There are certainly scenarios where a LiDAR would not function. There are scenarios where a radar will not function. There are scenarios where a camera will not function. So a way to think about this is as we are building up this on-ramp towards fully autonomous driving and fully smart cities, we want to have a system that is extremely robust. So if a camera fails at detecting a pedestrian 1 in 1,000 times, a radar fails 1 in 1,000 times, and a LiDAR fails 1 in 1,000 times, perhaps because there was fog at that moment, the combination is now a system that fails 1 in a billion times. Now, that is the kind of capability that now enables autonomous vehicles, driver assist systems, smart infrastructure to move towards that Vision Zero future that we're all talking about and we're excited about here today. So it's really not pitting one against the other, but using them all in unison for enabling a more robust solution.
No, I appreciate that. And Asad, that probably is a great transition, because I think as we think about infrastructure and infrastructure investment, how we look at our intersections, how we achieve Vision Zero, and what we put out there to be able to see to help make improvements are really important. And so talk to us a little bit about what you all are doing and how you see this future building.
Great. Thanks, Amy, and definitely thank you, Velodyne team and ITS America for hosting this event. When it comes to the safety of the intersection, interchanges, and other traffic facilities, in most of the time we assess those areas by tracking and analyzing police-reported motor vehicle crashes over time. Given the infrequent and random nature of the crashes, this process is slow to reveal the need for either the roadway redesign or flow control strategy. So alternative safety assessment approaches known as target safety analysis are utilizing new methodologies and traffic metrics such as conflict and speed analysis so we can proactively identify the risk and safety issues in a road network, and more specifically at the intersection for vulnerable road users. But the backbone of this type of analysis is the trajectory data of the road users collected by cameras. But the challenge is with using a camera, our analysis will be limited to a proper lighting and weather condition. But we see that the majority of the accident happens during the low visibility condition that typically a camera fails to provide accurate information. So to address these concerns with camera-based solution, our company has built a Lidar-based traffic monitoring and analytics platform that works in different weather and lighting conditions. This enables us to use the solution for traffic operation application as a replacement for radar and inductive loop detectors. But also can detect, classify, and track all the road users, including pedestrian and cyclists, which is really important for safety analysis and planning applications. And in most of the cases, with a single sensor at the corner of the intersection, it reduces the cost of the installation and maintenance. And it's already powered by 5G technology that enables us sharing the data in real time with connected vehicles and building more advanced features on top of our solution, and all without raising any privacy issue, which is a concern right now with deploying cameras in many places. So now let's see how it works. When you install a LiDAR at the corner of the intersection, it generates a real-time 3D image of the intersection emitting hundreds of thousands of laser beams every second. This allows us to construct the 3D shape of the object within centimeter resolution. And more importantly, measuring the distance between the object accurately without any need for the calibration, which is a key factor in having a precise conflict analysis and speed measurement. So once we deploy the LiDAR, the LiDAR data the LiDAR will be connected to our edge box at the intersection, which our perception software is running on that edge box and reads the frame of LiDAR cloud point data. Then the algorithm detects the object, classify them, and extract the trajectory of the road users. And this is basically the core of our technology. Then the extracted data, which includes, as I mentioned, the location of the object, class of the object, is passed to different layers of the application that I'm going to talk a little bit about those type of application. Through our platform, you can define customized virtual loop detector. This allows us to use the system as a replacement of inductive loop detectors or radar, with an option to extend the loops for pedestrian and cyclist the application, which is important for improving the safety for those type of road users. One of the main safety application that I want to talk is we built based on our core technology is extracting the speed data of the cars when we get the location of the object frame by frame. And then analyzing the speed of the road users over time can help understand driver behavior, measure the effectiveness of the traffic light timing, analyze the effect of event construction and weather and lighting condition and the road user speed, and even identify overspeeding in our road network, which is basically different layers of the information that we can have based on the speed data to have a better and safer and more efficient intersection. The second important application that I want to talk is conflict analysis, which is really important for safety improvement at the intersection. Our algorithm analyzes the trajectory of the road users to measure post-encroachment time for each pair of the object. PET is a factor that is used as a measure of conflict. It's highly correlated to the risk of accident at the intersection. And typically PET values less than 2 seconds classifies as dangerous, and from 2 to 4 seconds as a high-risk conflict at the intersection. Studying the distribution of the PETs over time helps identify the source of the conflict, the type of the road users involved in a conflict, and even generating 24/7 heat map of the conflict at each corner of the intersection. And when we deploy it in the city scale, and we get that information for different intersections, so we can prioritize how we want to move forward with our safety improvement projects. And then you can proactively identify the issue and solve it without waiting for another accident to happen. These are like just a sample application that we built on top of our solution. But what we see as a potential of this technology, the reliability of the LiDAR technology aligned with our perception software, our open API, and the 5G technology that we already have that enabled in our system, enables us to use our solution in a variety of new applications that we don't see in a typical traffic monitoring use cases, such as sharing pedestrian data with connected vehicles, detecting pedestrian crosswalk, extending the green time, especially in area with high elderly population, and generally speaking, improving the accessibility of the intersection for all road users, incident detection and emergency dispatching, and many other applications that we can build on top of the solution. So this was a brief description of our solution that addresses the current needs of municipalities with their traffic operation, planning, and safety application, and also engaging them with new use cases. And if you want to learn more about our solution, definitely I would be happy to answer the questions.
And, you know, as we go into this, Asad, I think one of the interesting pieces that people will want to learn more about, and at least I'm curious about, is those layers of interaction like we were just talking about earlier with Nikhil, which is, you know, the interaction you showed, for instance, connected vehicles on your slide, and the interaction that the data that you were pulling in real time from an intersection, its capacity to eventually interact with an automated driving system, even an ADAS system. And I think that will be one of the pieces that, as we are starting to move forward, I think people would be curious about. And maybe that's a good transition into Olivier, because Olivier, I think when people think about LiDAR right now, they think so naturally about how LiDAR is helping autonomous vehicles see, compared with you know, its radar technologies, its cameras, et cetera. And so I'd love to start this introduction with you as you can talk about NAVYA, which is again one of the leading automated driving systems in the country and in the world, frankly. And we are already getting a lot of questions, you guys, in about some of the technologies and some of the technical aspects of what you're doing. But Olivier, maybe you'd start by framing out NAVYA's information, because I think that we've got a lot of questions about how does LiDAR versus radar react? How far do they each see? And how are you taking that into account when you're developing your ADS systems? Olivier.
Sorry, I forget to switch on my microphone. Thank you, Amy. And I will start to present to you what we are doing on NAVYA side. Oh, sorry, my Écran. Okay. Can you see my screen?
We can, yes. Yep.
Okay. So, yes, it works. Just to say, we are mainly using LiDARs on our vehicles. We are also using some cameras, and we are sharing both information. We are using, I will share the videos. Yes, it works. We are sharing, we are using the LiDARs in many different environments and many different applications in many different countries. Just to say, yes, we have LiDAR on the vehicles. We are using it to sense all the environment, all the behavior of the people around the vehicles. And we are providing mobility solutions because we are sure that the private cars and the autonomous car are not the best way to provide mobility and the new mobility. We are using many shuttles in many different areas, coming from very, very dense urban situation to industrial cities, which are quite different, and we're able to use the LiDAR to localize the vehicles in any kind of situation. Even this situation with many pedestrians for airport, we have to take care of the environment, and we may have some perturbation from radars. And we are using on tourist side, sorry, because I'm a little bit on hospital too, and we are providing some vehicles fully autonomous, especially for COVID applications. In this case, you can see the vehicles operating in a dense urban area with many vehicles, and we have a technology which has been improved, and we have won some two major challenges in Dubai, even in this case for overtaking bicycles. Sorry for that. This is the two prices, but we are using also this technology for logistic applications. For this case, for chartered vehicles, we are dedicated to the transport of goods, and we are using that in industrial sites. This one in the airport. The previous one was on automobile factory. Sorry. And now we're able to use this technology for fully autonomous vehicles without safety driver on board. You can see some Velodyne Lidar on the top of the vehicles, and these vehicles are able to drive without any driver on board. But there are some interaction with the supervisions, and we're always able to stop the vehicle or to monitor what's on. Okay, that's the end of this one. Next one. Okay. And we want to provide this solution for our public transport operation, because we know that VTC, even if it's autonomous vehicles, are not able to provide the solution for every dense area like cities like New York, Chicago, Paris, London, every one of these cities. We know also that a vehicle is parked at least at 95% of the time. Then we have to have shared vehicles which are able to manage, I would say, peak of transport. We are able to drive at a different hour of the day on other situations, like providing some transport for disabled persons, and to be able to remove pedestrian accidents, especially on the crosswalk or at intersections. Then we will use some interaction with, I would say, detection of pedestrians at the intersections. The last one, yes. Then you can see the vehicles. We have the LiDAR sensors, many of them inside of the vehicles, for sensing the environment, but for sensing the passenger too. It's especially the case for doors applications. We want to be sure that everyone inside of the vehicles, that the doors are well closed, and that no one is touched the vehicle when the vehicle will start again. We have many different use cases we will provide. We have many partners. We have partners like public transport operator as Keolis. We want to change, I said to you just before. We are able to operate in many different areas, especially in Lion, we have a specific application touched to the Olympic Stadium, which the vehicle is able to drive in a fully open road. There is 8 crossings. There is 10 crosswalk, if I remember well, and the vehicle is operating in a safe mode every day of the year. Even if it's raining, we will just adjust the speed of the vehicles depending on the environment. What I can say to you too. Yes, this is the application on Chateau, which was on the movie just before. The vehicle is fully autonomous without any safety operator on board. We have a remote supervision center. We will monitor the vehicles at any times, and we will be able to see even at the supervision center what are the sensor situation, if the sensor identifies some interaction with the environment, like a car parked just there, and we will provide an operator who should come to operate the vehicle manually if there is any perturbation on the road. Yes, this is the last one.
Thank you, Olivier. And you know, I think that one of the questions that folks have, especially as you guys are moving into your level 4 autonomy, is, and maybe you can answer this, and then I'd also like Nikhil to maybe approach this, is the question that we're getting is, what is the distance that your LiDARs and your radars have to detect the pedestrian? And so the difference in the data between a LiDAR detects at 200 feet or 200 meters, and radar is only at 150, or et cetera. And people are curious about the difference, and especially then when you all layer them on, how does that grow your capacity to see? Olivier?
Yes, it depends on the speed of the vehicles. At this time, we are driving at 20 kph. We are using LiDAR for sensing at, I would say, 100 of meters, and to be sure that we rely on the detection of the sensor. But we will use, if there is any perturbation of the sensor, we will reduce the speed of the vehicles, and to be sure to be safe at any time. And we will use some cameras for us to have the coherence between both of them, because we will be safe at any time. But LiDARs provide quite well perception for the vehicle.
Actually, gotcha. And Nikhil, do you see the same, and sort of how you're looking at just sort of the pure technology side of it and the capacity to see at distance?
Sure. Yeah, I'll similar to what Olivier said. LiDAR is especially useful for this particular problem, because if you think about a radar versus a LiDAR versus a camera, a LiDAR is capable of seeing up to 200 meters. And it has the horizontal and vertical resolution that is necessary to distinguish a pedestrian's form from the surrounding environment. Whereas a radar, traditional radars, I know there's some new technologies in radars, which I'm personally not very familiar with, but traditionally radars have a higher angular discernibility. They have lower angular discernibility just because their beams are wider. They don't have a narrow beam, they have a wider beam. And so when a person is further away, they get encapsulated with a larger beam. So it's hard to tell a pedestrian apart from something else in the environment. So that's one place where a LiDAR is very helpful. Cameras with very, very high, magnification and high number of megapixels can certainly also be helpful. But in that combination, LiDAR really tends to be very useful in detecting pedestrians further away.
Well, and that actually comes to another question that we've gotten in, obviously for our audience. Thank you for already putting questions in, and especially on the technical side. So we'll talk a little bit about the technical, and then we'll go to some bigger pictures on policy and approach. But, the question was about cameras and the classification and what LiDAR can see versus the RBG camera. And Asad, maybe you could talk a little bit about that, because I think that that's one of the natural questions that people ask, especially if I am a city DOT, and I'll put that old hat on now. And if I've already made an investment in cameras, why would I be thinking about, investment in LiDAR? And does that really sort of expand what I need to see in regards to how do I get to that vision zero?
Yeah, I think one of the main challenges with investment on the camera is that we see cameras. The main reason was that we didn't have any technology to capture the pedestrian data. So we have radar inductive loops that we are using them for many years for traffic operation application that we just needed to detect cars. But when it comes to the safety application and pedestrian especially, we need to have a solution that works to detect the object and classify them. So that's why we see cameras. But the challenge with the camera is that if you want to really have a full intersection in terms of having technology for traffic operation and also for safety and planning, we need to put a combination of the technologies. Radar good for operation, camera good for pedestrian and planning. So that's why we see there is a great opportunity for LiDAR because it addresses the challenges of both technologies. And definitely one of the interesting aspects is that with LiDAR, there's no privacy concern, which really helps the municipalities to justify why they need to invest in new infrastructure.
Yeah, privacy is one of those constantly moving targets in how people talk about it, how they engage in it, and how they invest in it. And, one of the questions that was a follow-on to that is whether or not the Blue City technology deployments are embedded. And is that the case?
Yeah, so everything is an embedded solution that you just deploy at the corner of the intersection. The only thing that typically you need is a SIM card. You put all the data will be available 24/7.
Well, as we talk about technology, and one more question that came in, Nikhil, that I think was directed at you, so to ask you to answer it, is they were curious about your tests and your visibility tests, and they were wondering if your tests were against the NCAP VRU standards, or were they a sort of an in-house comparison? Which were they?
We do both. So for those who are not familiar with that, there is a standard set by the Euro NCAP that's known as the Vulnerable Road User, the VRU tests. And these are tests that involve having an articulated pedestrian dummy cross the street in front of the moving vehicle, move alongside the vehicle, emerge from between two parked vehicles, orthogonal to the direction of travel of the vehicle. And these are all the kinds of experiments that we do conduct. What I presented there was just one subset of these kinds of experiments, but we are on top of all of these different experiments. And in fact, we expand these to not just work in the daytime, but the nighttime as well, because a lot of the Euro NCAP requirements do not dictate the time of day. And so a lot of the car companies that conduct those tests conduct them during the daytime. And we are champions for expanding the operational domains and the scenarios in order to more fully capture the essence of the problem.
And I'd like to talk a little bit about standards here in a little bit, but I actually wanted to go a little bit bigger picture in regards to our autonomous future and the safety of that future. And Olivier, while you all are building effectively vehicles for fleet, which is clearly, I think, where most of us and many of us believe that the AV deployments will start in a fleet side, whether it be with transit fleet or perhaps even freight fleet as it continues to move forward. We got an interesting question about AV kits as it relates to personal vehicles. And, as you all think about the monetary investment to build this kind of detection system that supports how you create an effective AV driving system, do you think that from a bigger picture, as it starts moving into personal vehicles, that consumers can absorb the cost that it would take to put this triple layer in of cameras, of radar, of LiDAR, and, perhaps just on a bigger scale? If you personally were buying a car, how would you look at this future?
I'm not sure that consumer will assume the cost of these kind of vehicles, because the kind of vehicles will have to be very expensive to cover all the use cases of the consumer, for private consumer. If you want to have vehicles level 5, you have to be sure that you will be able to cover any of the cases. It's quite easy, not easy. You can provide some system to have highway pilot for the vehicles, and you will need maybe not so many sensors because you don't have pedestrian or other such many sensors on the vehicles. If you want to drive in dense area, you have a business model which is quite different, and you're able to provide a good system with LiDARs on the vehicles, with a fully safety sensor sets, which allow you to drive on this kind of very sorry for my English, in this kind of situation. In this kind of situation, on the business model, it's quite easy to reach, because you will have a return for the investments comparing to operator vehicle with a driver, which is quite low. And we will have a supervision on the safety operator on the operating system. Will operate 10 vehicles at the same time. then you will be able to provide some solutions for this kind of applications. And you will not provide some traffic jams, because there is the problem of the traffic jam. If you use a car, maybe you have to pay for $50,000 to have an autonomous vehicles. And this autonomous vehicle is parked more than 90% of the time. It's just a pity. You will have some taxis or VTCs. It's much more efficient.
Mm-hmm. Well, and I think that as you get into this, the other piece that you talk about is, again, those assurances from a broad safety perspective in what all you're seeing and how the consumer becomes very comfortable with this kinds of technology as it layers on. Nikhil, I'm curious your perspective on this that same question, because it's one of these natural pieces I think that we all get into here, is the transition and the transfer of cost when it comes to technology applications. Now, we all know, and this is a very old one, but the new iPhone has LiDAR, right? That was the big pronouncement. Oh, LiDAR. And I think people see LiDAR in an iPhone as the same as the kind of LiDAR that we're talking here. And I know that all of our attendees well know that we're not talking about the same thing, but the perceptions of what that is and what that costs and the accessibility to a consumer when they get into this world is I think, going to be an interesting one.
I think that's a very valid point. At the end of the day, people are making their buying decisions based on what comfort is being offered by these technologies. So people generally don't actually, there are two different categories. There's passenger vehicles and then there's commercial vehicles. When we talk about passenger vehicles, people don't think about safety first, or they don't like to pay for safety. They want safety to be inbuilt and inherent, implicit, but they'll pay for comfort. So they will pay for that blind spot monitor, which they'll use on a day-to-day basis to change lanes. So they'll use the backup camera to back their vehicle up, or they use a lane keeping system to keep the vehicle in there. But if you have an emergency braking system that they don't even know is on there and activates 1 in 1,000 times, they're grateful they have it, but it's not something that they would think about paying for. And this is where regulation needs to come in, just like the need for having smoke alarms and fire alarms in your building. It is for the greater good of society to have this in all vehicles. But on the other hand, what we do see in commercial vehicles, though, is there is a need for safety. If a company operates, let's say there's a small company that operates delivery vans in one city, they have 20 vans, a single van has an accident with a pedestrian, the insurance premiums of all other vans naturally go up. So they are incentivized to invest in safety, not only of the driver, but of the pedestrians and others as well. And so that combined with the need for more comfort is really what's going to enable this. But the third piece is really government regulation mandating improved safety for the road users.
Well, and I think you hit the nail on the head, as I was actually going to shift into that, which is the government and the regulatory piece of this. And Olivier, you probably have some experiences because you are dealing across the world with different government and potentially regulatory bodies and standing setting bodies. And we were having this conversation the other day, and Asad, maybe I'll start with you because we were talking about this, is when we look at the different layers of technology that help us see and to enhance the safety, we have the vehicles and the ADAS systems, or even the automated driving systems themselves, the regulatory environments that are or are not happening and sort of mandating certain standards and expectations about what's happening in safety, whether it's the vehicles self-certifying in safety or whether it's a more regulatory environment that requires certain things. You also have the intersection with the intersections, pun intended, on other infrastructure deployments that you're seeing from a technology perspective. And I'm curious about whether or not we are needing to see a more comprehensive standards-based or even regulatory process that create a consistent understanding of how we achieve safety in these environments. Is it still the Wild West out there in regards to what we're looking at? And would we benefit from a tighter regulatory, even a better standards environment that gets us to this point, especially when you have all these technologies intersecting?
Yeah, I think for many years on the like, let's say, how we moved cars around the intersection and in a network, we have really like a solid like policies around this built by governments about, okay, what should be like the minimum accuracy of a technology in sensing a car, what should be the reliability of a traffic controller, and we had different type of certification that all those technologies should pass. But I think the missing point right now, especially with the safety aspect and pedestrian, is we don't have those type of minimum requirements for an intersection to run in a safe environment. So like, we don't have any like obligation by or mandate by governments to force the municipalities, okay, you need to run a certain type of studies at least once a year, twice a year, to study and report the safety metrics. And this is like all happening based on the crash data, which is a rare like incident. So I think that's a missing part, and I think we need to get to the point that like doing safety improvement, analyzing the safety of the intersection from a nice to have feature should be like a must to have feature for municipalities and even their daily activities. And well, I think we have in the technology side, we have those capabilities these days. So yeah.
To create that standard and that almost regulatory environment. And Olivier, you had mentioned that it's complicated. You were talking earlier in your presentation about the fact that one of your challenging use case scenarios right now was an intersection where you had 4 crosswalks plus pedestrians moving through that environment. But you also recognize that standards are tricky when it comes because you've got different countries, you have different behaviors from pedestrians. Let's just say how someone interacts in Midtown, United States might be different than how someone is behaving in the middle of New Delhi. So it's complicated in that regard.
Completely agree. The French pedestrians are not the same that the US ones. They don't have the same behavior on the road. They don't act the same way. Some of them are crossing the road that they were crossing. Some of them are not. They are just crossing the road where they want. The size of the road is not the same in different countries. We are operating vehicles in 22 different countries with many operations. The regulations are not exactly the same in all the countries. The behavior of the people is not the same. And even if I certify a vehicle today, tomorrow I can have some modification of the environment. It can happen some new scooters, some new behavior of the pedestrian, and I have to rely so many sensors to be sure that I will detect what will happen. And pedestrian is a good example, because at the beginning it was only pedestrian intersections, but e-scooter is quite the same as pedestrian. And to make a difference with cameras from a pedestrian and a motorized pedestrian with an e-scooter is quite difficult. And the behavior on the e-scooter is not exactly the same as the pedestrian, also the same speed. Then I have to be sure at any time I will detect all the modification of the environment, all difference of the behavior, and I have to be sure that I will monitor my system at any time to detect modification of the environment.
Well, and I think you just brought up a really interesting point. And myself, as a scooter rider who tends to want to cross intersections on a sidewalk rather than on the road, just from a personal safety perspective, I perceive that as being safer, but maybe it's not. And Nikhil, I'm interested, as you guys sort of, can you see that? Are scooters different, for instance, than pedestrians? And I suppose it falls in the framework of a bicycle or even an e-bike, because of the speed with which we're moving is a little bit different. How does that work from a technology perspective?
It certainly is different. It's the speed at which people move on scooters is more akin to a bicycle. But they don't have the same sort of volume that a bicycle has. So it's certainly a challenge. And this is something that we are starting to see in the data I live in San Diego, and this is a city where everyone uses scooters and all new types of new mobility platforms that this is like a test bed for all of these. So I do spend a lot of time thinking about that, and it's indeed difficult to try and predict how be it LiDAR, I think, would perform with all of these new types of mobility. But when it comes to scooters specifically, this is something that we have seen a LiDAR-based system can be helpful in isolating compared to a camera-based system. What tends to happen with most of these things, like cameras, for example, right? And by the way, this is not I'm not proselytizing. I'm just calling out just technologically from first principles what the differences are. But the camera-based system, you're using a lot of machine learning. You're using training. What is that cluster of pixels is what you're trying to identify. And when you start seeing people in new configurations, be it on a scooter or on a new type of mobility platform, these are the outlier scenarios that those systems tend to fail at. LiDAR, on the other hand, perhaps there are times where it won't recognize that thing is a person on a scooter, but it'll definitely detect that there's an obstacle here moving at this velocity. So that gives it a very, very high recall, which is very low false negatives at detecting something, making it absolute must-have from a safety perspective in urban scenarios.
That's interesting. And Asad, I suspect that will be stuff that you're incorporating into some of your technology platforms as you continue to move along with all of this. We got a very technical question, and so I do want to ask it because I think, again, it's just, people are curious about this. So here's the question. With 128 beam LiDAR, we get a point every 30 centimeters at 85 meters. So how is it that pedestrians are being detected with less than 3 points? And maybe, Nikhil, that's a question to you.
Sure. So we at that kind of a distance of 80, 85 meters, we do have a number of channels. And so if we think of a pedestrian who is 6 feet tall, 183 centimeters, that gives us 5 lines, each one having 3 to 4 points, which is sufficient data to distinguish them as a person. And that's just with one snapshot. But the beauty of LiDAR is it is a continuous, it's like a stream of consciousness. It is spitting out data as the vehicle moves, as the person moves. And this is where software comes in and takes all this temporal information and conflates that to create a more representative and high probability map of the dynamic world, including detecting pedestrians. So it's not a one snapshot problem. So as we're driving towards the an intersection where a pedestrian is crossing, we are getting multiple observations, and so it makes it possible to improve the detection probability even as you approach the pedestrian.
Well, and I think that one of the pieces that people are seeing as the technology continues to advance, and we actually have some questions about sort of what's coming next. But I one of those questions was about, and Asad, you're sort of in this framework a little bit, is, someone believes in LiDAR technology. They're talking about the complementary nature with other sensors like radar and cameras. And they foresee its use, in cars and vehicles, and Olivier, you're pointing to that. But what do you think about after sales services of maintenance and LiDAR sensor calibration? Asad, you guys deal with this because you're insetting it and you're putting it into an intersection. Obviously, you're putting it into one traffic cabinet as opposed to needing 4, for all of the different cameras because of the way your range of vision works. But how does it work when if I'm a DOT and I want to go in and I have to have maintenance on this, the capacity to do that? What do you see about the after sales side of this?
Yeah, so first of all, when we install, like for all current projects that we are doing right now, and more specifically the one with City of Montreal, which, it's really, we have a harsh environment, very cold winter, minus 30 degrees Celsius, lots of freezing rain, snow. And we had really hot, humid summer. And two of our sensors actually running since last year. And we didn't even have any maintenance so far. So there, and for all the projects, because we wanted to test this performance measure, and we exposed the sensor without putting any cover or like, let's say, any hat to cover like the LiDAR. But there are a couple of factors that definitely we are monitoring continuously to see when we need to, let's say, clean the LiDAR. And let's say we measure actively the intensity of the signal that we are getting back from the object. And when we see like over time, if this intensity drops, we see that, okay, so the laser beams, maybe like the glass in front of the sensor is dirty, we need to clean it. But at least for the over like more than 1 year that we deployed sensors, we didn't need to like clean the LiDAR yet. But again, like the maintenance will be very similar to cameras in terms of like how we can wash it. The LiDAR that we're using with Velodyne, so you can power jet it, power wash it, and you don't need to really send someone to clean it. And the glass itself is dust proof, so the dust won't stick to the glass. So these are like the different aspects that helps with the maintenance of the system.
That's really interesting. So there is an aftermarket, but it's you're telling us it's performing pretty well, even in some pretty harsh environments. And that's one of the last questions that we were getting in. And I'm going to ask a question to the panelists before I do. You're going to see it pop up in your chat about the future of AV and LiDAR technologies and whether or not you see it as being something that is really going to drive how we continue to improve safety. But let me ask a question about interference. So you have your LiDAR in an intersection, a NAVYA shuttle is coming through the intersection, and are we concerned, and people are curious about your strategies on how you deal with potentially the sensors interfering with each other when it comes to the transmittal of data into your systems? And maybe Olivier, why don't you talk about that first, because yours is the one that's actually on the road then driving and needing to see in that active moment.
It's with some LiDARs at the intersection, it will be very interesting for me because I will be able to see some pedestrian, even if there is some occlusions. It could be some cars, some trucks, some vegetations will provide me some occlusions, and I will not be able to detect some pedestrian. Then I will act in a different way if I detect some pedestrian when I'm turned right, and there is a urine cap test for that. And sometimes you're not able to detect the pedestrian because there is some car parked, and I have to reduce the speed of the vehicles with collaboration with the infrastructure on this kind of LiDARs. This is very efficient, and this is used for safety. The other point, if I have to rely on LiDARs on intersections, I have to be sure that the detection of the pedestrian will always occur. Then we have to exchange each other on what is the reliability of the detection of the pedestrian for this kind of infrastructure. If I'm not sure that this kind of infrastructure will detect at any time the pedestrian, I will have to assume that even if there are no information coming from the infrastructure, I will have to assume that there is some pedestrian in each. But when I will have the information, I will adjust the vehicle, adjust the behavior of the vehicle anyway to be in a safe way.
Right. Gentlemen, what do you think as you look at this space? Do we risk challenges of being over-censored and consequently negating the capacity to really see in the safety side?
I think LiDAR, same as radar and other technologies, is evolving very quickly. And one of the challenges that we one of the question about how pedestrian can be identified in 85 meters range when we have lower resolution, some LiDARs down the road will be able to, with software, change the resolution for far distance and have higher resolution for far distance and lower resolution for close distances. So I think this is the interesting part about the LiDAR market, which is evolving very quickly, longer range, higher resolution, lower price, and definitely the new ways of the way that the LiDAR manufacturers are processing the laser beam data to be able to avoid any inference between different LiDARs in one intersection.
Well, Nikhil, why don't you close us out as we're finishing up and talk a little bit about that future and where we see this going here in the next few years. And we're getting some of our attendees responding back, and I'll just read you one note. One of our attendees said, yes, they see this as being part of the future, especially if the regulatory environment catches up. And making LiDAR accessible to the everyday consumer isn't as important in his opinion, because the everyday consumer is being kept safe because LiDAR is being part of everything else, but that the regulations also need to evolve with all of this.
I believe that is correct. I mean, regulation, if not for regulation, there'd be so many things that wouldn't happen. We wouldn't have clean roads. We wouldn't have good infrastructure. We wouldn't have bridges. These are all things that the government and the public through mandates comes about. And I do believe that LiDAR is going to be extremely useful. And so each individual consumer might not have to think about having LiDAR. But I will say one thing, that people think of this as going to happen so rapidly. It is slow. I mean, just in the US, there are 400 million vehicles that are on the road. Now, if 10% of all the vehicles had LiDAR, that's 40 million vehicles. Even in that scenario, the probability that two vehicles that were next to each other had LiDAR is only 1%. Right. So the amount of penetration that needs to happen before that kind of a future is really, really high. So in terms of what our effort over here is to really educate the market that, the downsides are very, very minimal to non-existent. It's all upside. And so it's really about getting to that point faster through the help of government mandates, through the help of improved use cases like the ones that Asad and Olivier are tackling, bringing this public adoption of this kind of features and use cases. Because at the end of the day, consumers don't need to know that there is a LiDAR inside of it, but just need to know that it is safe because of all of this technology inside of it.
Nikhil, I think that's a perfect way to end this webinar. And I just wanted to say thank you to Asad, to Olivier, and to you for joining us today. Thank you for the really great questions to those who are attending this conference in this webinar. Fantastic discussion as we all remember why we're all in this business, which is to keep people safe on our roads, really to improve the quality of their lives as they get from point A to point B. So thank you so very much.
Thank you, Amy. Thank you for moderating. Thanks, everyone.